Yeah, well, what I want to do with you in the next hour is introduce you to a pretty cool new feature that Progress has developed for OpenEdge 12.7, support for .NET Core in the OpenEdge runtime. It builds a lot on the OpenEdge GUI for .NET features that are there since OpenEdge 10.2a, released 16 or 17 years ago. Talked you through some of the similarities and differences between the .NET that has been there. I will have to start with some of the confusing bits, and naming is more than confusing. I think Microsoft has tried to beat every other confusion and be even more confusing with their namings. So I'll try to provide some clarification there, and then what it is, what we can do with this, and how it works. Good. Quick introduction about myself. On the right-hand side, that was a lucky find yesterday. My mother is currently moving from a house into a small apartment while cleaning her basement. I found a box, and when I opened that box, my first ever Progress training certificate jumped on me. So that was an official training at Progress Software in Cologne, the German subsidiary, transition V6 to V7. I've started using Progress with version 5. That was a more self-introductory or introduced by the colleagues. I'm working as a director founder at Consulting Werk, but I prefer to be involved still in technical roles. Such I'm supporting our customers as an architect during modernization projects. I'm responsible for the development of our tools. We provide add-on tools to OpenEdge, developer frameworks, developer toolings like the Smart Component Library. And they have roles like product manager, architect. But when I really have a great day, then I even get the chance to do development myself. I like to work with the object-oriented features in the language, but well, I've seen enough of procedural code, so I understand a lot there. Let's look at what we do at Consulting Werk. We provide consulting service to companies that develop with OpenEdge, that are either software partners of Progress Software or direct end customers that build applications for their own purpose. OpenEdge is really the technology that we deal most with, but of course there are other technologies that are involved in modernization projects, especially front-end technologies. .NET is a big thing there, but also web technologies like the Angular framework or things like that. With Consulting Werk, we're a distributed team. Our main office is in Cologne, and later in this presentation, we will see some .NET code that shows us exactly how far away that is from the Burlington office of Progress Software. With subsidiaries in the United Kingdom, in the United States, and Romania, with colleagues working from home offices in the Netherlands and in Czech Republic. And from there, we're supporting our customers in Europe, North America, Australia, South Africa. Besides the focus on OpenEdge, there's other Progress products that we have quite some expertise with and supporting our customers with. The various Telerik products, the DevCraft suite, the .NET or web front-end components, Telerik reporting, the Infogistics controls that Progress provides for use with .NET framework. Telerik, well, no longer a product from Progress Software, but we're still supporting customers with its native script for building mobile applications. Corticon, WhatsApp Gold, Camp Loadmaster, so various of the older or newer products of the Progress product portfolio. Besides the Progress products. There are other products, third-party products that have some relevance in the Progress environment and the Progress ecosystem that we provide service for. ProTop for database monitoring, something that we support our customers with. List and Label is a reporting tool from Germany that can very nicely be integrated with OpenEdge. Web frameworks like Angular, .NET, Java, either for UIs or integration technologies, Elasticsearch or Lucene for improving search capabilities in OpenEdge applications, and then DevOps and deployment options, Amazon, AWS, Azure, all those are areas where we support our customers. So let's start with the topic of the talk today, .NET Core and OpenEdge. I'm going to start by introducing .NET Core and how it distinguishes from any other .NET. Then I'm going to talk about a bit the history or the status quo before 12.7 of .NET and OpenEdge, and then I'll dive into what it means to use .NET Core with OpenEdge 12.7. I'm going to talk a bit about consumer asynchronous APIs, because when you look at modern .NET class libraries for various APIs, more and more APIs are implemented in asynchronous fashion. And then I'm going to end by doing some relatively trivial benchmarks, but they show very nice results. So before I start talking about .NET Core, I have to talk about the .NET framework. The .NET framework is the .NET that Microsoft has started developing. Development started in the year 2000. First version released was then in version 2002. The reason why Microsoft started developing the .NET framework was that after, they were kind of coming to an end with the ActiveX and COM technologies. Microsoft was first trying to modify Java to provide better integration with Windows applications. Sun Microsoft didn't like it at that time and sued Microsoft, and then Microsoft basically said, hey, Sun, if you don't let us change Java in the way we want to change it, then we build our own Java, and that was basically the birth of the .NET framework and C# as a new language, which started pretty much with a very similar syntax to Java. And then over the last 20 years, Microsoft has been providing new releases of the .NET framework. One big milestone was the .NET framework 2.0, where I think it really became the mainstream for developing OpenEdge GUI applications. Then there was a version 3 of the .NET framework where new front-end technologies with WPF and new integration technologies with the Windows Communication Foundation and the Workflow Foundation have been added to the .NET framework. 2009 was a release of the .NET Framework 4.0, a new version of the CLR, some new features in the runtime. And now we're seeing with the .NET Framework 4.8 the declared last version of the .NET Framework with new features. The .NET Framework will still be maintained by Microsoft. It will probably for a very long time be supported in the way that you can execute it in a new version of Windows, and that either bugs or security issues will be resolved. But as of today, Microsoft says, 4.8 is the last version, no new features, but we all know that also Windows 10 was supposed to be the last version of Windows, so who knows for how long that stands. But right now, we need to consider that the .NET Framework 4.8 is feature stable. And why that? Now there's .NET or .NET Core. And this is where the confusing bits with naming start. I mean, the .NET we've been using for the last 20 years, everybody's been saying, hey, that is .NET. And now we need to be very carefully distinguishing that this is now called the .NET Framework, and there's now a new product, a new variant of .NET standing beside the .NET Framework that is just called .NET. It used to be called .NET Core, but with version 5, Microsoft has dropped the core from the name, so it's just called .NET now. The history there, it started as being announced as the cloud-optimized .NET framework. Part of the cloud-optimized it started focusing on web applications and not desktop applications. It has an integrated web server, and it can be deployed on other platforms than Windows. And for cloud deployments, well, with Linux as a backend, typically the deployment can be cheaper than if you deploy your applications on Windows. Yeah, well, the first version of .NET Core was announced in the release candidate as version .NET Core 5.0. Microsoft wants to indicate some form of continuity with the .NET Framework 4 releases. And when they then released it, they released it at .NET Core 1.0. So it looks like Microsoft needed a little bit of time to find the correct naming and, yeah, even more confusing naming. One of the reasons why I believe that Microsoft has chosen different naming pattern is to make sure that with the development of the .NET Core framework, they are not a full compatibility to the .NET Framework 4.8 has never been a design goal. Microsoft was accepting from the beginning breaking changes compared to the .NET Framework. There are a few, when you read about that, it always sounds like no application will just work using a load and go or recompile and go. My experience is the opposite, that most applications will just work fine when you recompile them. Yeah, and with the naming, then like with .NET Core 5.0, the core was dropped from the name and it was just became .NET 5. So from there we had .NET Framework 4.8, which is the variant of .NET that we've been using in OpenEdge since version 10.2a, and now there's an alternative called .NET 5.0. Then .NET 6.0 was released, I believe, last year. One of the focuses on the development on .NET 6.0 was the .NET Windows user interface has been improved there. So there's a WinForms UI that we know, but also performance improvements have been the focus of development there, and even more in the .NET 7.0 framework. A lot of, especially the early influences on the development of .NET Core came from the Mono framework, which was an early framework probably over 10, 12 years ago that ported the .NET framework to Linux and Macintosh machines. Initially, it was not a development from Microsoft. Miguel de Casa, a very popular developer involved in many open source projects, has been the driving force behind it. Microsoft has then acquired the company of Miguel de Casa, and with that, yeah, .NET and Mono really moved together into the direction of that what then became .NET Core. We see there's a new version of .NET Core since 2016 every year. And every second year, there's a version that is a so-called LTS version. The version .NET 6, which is relevant for us in OpenEdge in 12.2, has been released last year. It's considered long-term support, so Microsoft will be providing fixes when necessary for .NET 6 until November 2024. So for Microsoft, 3 years of supporting .NET is the LTS time window. I think that's something where in the OpenEdge world, we are much, much better served by the vendor. And with the name, even though Microsoft has officially dropped the name .NET Core, if you read in the internet and talk to developers, everybody still calls it .NET Core. And I think it's just human. We need something that distinguishes .NET framework to the new thing. So I'll be talking sometimes here about .NET. Most of the time I'll be talking about .NET Core, and I mean the new version of .NET following the release schedule from the previous slide. And even Progress Software seems to be going with this strategy, because the startup parameter that has been introduced with .NET with OpenEdge 12.7 to enable the support for the .NET 6.0 is called minus CLR.NET Core. So the core is also part of that startup parameter. So goal of .NET Core is also to provide platform independence. So there are variants of that for Windows, of course, various Linuxes, and Mac OS X's, and even for ARM CPUs. It's open source, so you can download the source code for the .NET 6.0 framework. It focuses on C# as a programming language, F# as an alternative. There's some VB.NET, but VB.NET is really, the Visual Basic .NET is not really the most completed language in the .NET Core world. Tooling wise, there is tooling support, first-class tooling support for it in the Microsoft Visual Studio. Visual Studio Code as a more lightweight editor, favored by especially web developers. But there's also a huge trend towards Visual Studio Code by OpenEdge developers. Those graphical development environments, of course, provide support for it, but a design goal of the .NET Core framework is also to provide the ability to do everything that you need to do as a developer, also from a command line. So much like with modern web frameworks, and that makes scripting much easier, and all sorts of automation. And there's some limitations. .NET Core is not just the new version of the .NET framework with carrying over all features. Microsoft has dropped some features which they probably felt they don't need them anymore. So for ASP.NET web developers, the support for .NET Forms has been dropped. There's still some ASP.NET Core MVC UI framework still there, and there's Blazor as an alternative web development solution. Blazor is kind of like Microsoft's version of Angular from the programming model. The Windows Workflow Foundation has been dropped. The Communication Foundation has been dropped. Communication Foundation is probably no longer needed since REST services are the way how all applications communicate with each other. And Microsoft says there's some limited support for Windows, but the term limited sounds really much worse than it is. On Windows now with .NET 6.0, there's a pretty feature-rich variant of the Windows Forms UI, the one that Progress developers typically use in the Progress runtime. There's some known breaking changes. Microsoft has dropped some controls from the .NET framework, but if you look there very close, the controls that Microsoft has dropped are those controls that has been introduced with the .NET 1.0 version framework 20 years ago, and the .NET 2.0 framework 15 years ago or so has already replaced them with new versions. Today, no .NET developer writing a desktop application would be using the Microsoft Data Grid control. Microsoft has been recommending to use the data grid view since long, and the same is with it's a relatively small number of controls here. They are no longer there. If you're using them in your application, then you have a problem. My experience is that most developers have started with the newer variants anyway. But there are also some core benefits. I mean, it's the design for the web. Brings in the web server, containerization of applications is much easier. Also because it's operating system independent, you can deploy it on Linux. Well, the fact that the .NET framework development is no longer providing new features means that for all new features, you can expect them in the .NET Core line of frameworks, but no longer in the .NET Framework line of frameworks. There are new UI technologies like Blazor for web applications. MAUI is multi-platform app user interface is Microsoft's current technology to build native applications for Android mobile phones, for iOS-based mobile devices, for Mac OS X, and for the Windows desktop. And there's a package manager, which is an important part of the infrastructure, pretty much like NPM for web applications. NuGet is the package manager for the .NET world. it gives an easy way to third-party libraries and allows to update them using command line or integrate in the various visual designers, etc., etc. Good. Now let's look a little bit about what OpenEdge has provided in the past already in .NET support. So to my knowledge, the first touching point between OpenEdge and the .NET framework was in 2003 with the release of OpenEdge 10.0, the introduction of the Open Client toolkit for .NET. If you look at the release history of the Microsoft .NET framework, that was just 1 year after Microsoft has released the .NET framework. I think that was a pretty quick reaction from Progress Software. I did find mixed information there, either in 2007 or 2008. That was probably the largest development done from Progress towards the .NET framework was the introduction of the OpenEdge GUI for .NET. With GUI for .NET, you can use from within the within the Progress GUI clients, .NET user controls. At that time, 2007, 2008, the Microsoft .NET framework was without any real competition, the most modern desktop user interface technology for the Windows PC. And well, at that time, the Windows PC really didn't have any real competition for at least for business applications. The GUI for .NET feature has then in the following years been enhanced. In the first release, the license did really restrict us to only use the GUI for .NET Bridge for UI use cases. And then after further testing, Progress has lifted this license restriction. And since version 10 to be, and I don't know if that was a service spec that you had to be on or not, Progress did allow us and does fully support using the bridge that initially was built for GUI application for non-GUI use cases. So using other .NET APIs than pretty user controls. And soon we'll be seeing some trigonometrical functions as something that the ABL lacks out of the box, but you could be using them from the .NET framework quite easily. With OpenEdge 11, Progress has lifted the .NET runtime from 2.0, which was used in the 10.2 releases, to .NET 4.0. Now 12 years later, with OpenEdge 12.7, we now have the optional use of the .NET 6 runtime. .NET 4.8 remains the default runtime. And I have no information if Progress ever intends to change that. And I would be assuming that that would be subject to how much we, the customers of Progress Software, are going to adopt the .NET runtime versus sticking to the 4.8 framework. In the time between, Progress did more like product maintenance changes, so necessary bug fixes, or minor improvements to the language. Progress provided from the beginning a set of .NET UI components, not out of the box in the sense that they were part of the license, but Progress sells a product called the OpenEdge Ultra Controls, which is just the Infogistics Net Advantage set of .NET controls, which at that time was the market leader for .NET controls. Progress used them for in development for QA. There are a lot of samples for using the Infogistic controls in documentation and trainings. Tech support knows a lot about that. 7 years later, Progress has acquired Telerik. Telerik is a company that, is more or less a competitor of Infogistics, has also UI front-end technology components for the web. That was the main reason for buying Progress, and from a customer's point of view, it feels a little bit that when Progress then looked into the box of things that they have acquired, they took out all the web technologies that they wanted to have, and then, there are also .NET controls. What do we do with them? Okay, let's see if our customers are interested. To many people's surprise, and I'm one of them, it took quite a few years to gain the same level of stability of using the Tilrig.net controls within OpenEdge than at that time you had within Logistic controls. So that was Tilrig wasn't really bought for the .NET controls. That is my take from this. I still prefer using the .NET, the Inflogistic controls, and that's a combination of I've been using them longer, I know them much better, I know them by heart, and even now you find certain things with the Tilrig.net controls that are more complicated to use in the OpenEdge environment than the Inflogistic controls. What are the components of the support for .NET? Well, the .NET runtime, the CLR, Common Language Runtime, is loaded into the OpenEdge client together with the AVM, the Progress, the ABL virtual machine. So you have the two virtual machines in one process, and Progress established an inter-process communication called the bridge. So it's not based on any messaging, not based on any network protocols. It's in a process for best performance. The ABL can create instances of .NET types of classes, set properties, invoke methods, subscribe to events, much as if that would be ABL classes. If you look at the bit of source code in the ABL that uses .NET classes, you can at the first sight not distinguish whether it's using an ABL class or .NET class. ABL classes can inherit, can extend .NET types and override methods then. And very important for database applications is there's a data binding component that allows to hook OpenEdge queries and temp tables and pro data sets to .NET controls like a grid or other controls that visualize data. Error handling is integrated. .NET exceptions are integrated in error handling. You can use .NET types as an extension to the ABL, and especially for GUI applications, the classic ABL GUI applications, so usually the gray screens and the .NET forms, they coexist in the same runtime. And there's even a feature that allows to embed .NET controls, ABL windows into .NET forms to provide a very tight integration there. And there's a lot of tooling support. So there's a visual designer which has the same features because it's based on many of the same components as the visual designer in the Microsoft Visual Studio. You can drag controls there. You get a nice snapline support for arranging controls relatively to each other, and so on. You get all the wizards that the control vendors provide. All that makes building applications really nice. In the Visual Studio, in the Progress Developer Studio editor, you get code completion, both when you use the out-of-the-box editor, but also when you use OEDT, which is an extension to the Progress Developer Studio, not from Progress Software, but Riverside, which is also a third-party tool vendor for OpenEdge developers. They are providing a language server for use in Visual Studio Code, and that also provides nice code completion for .NET framework classes. There's a class browser, there's a tool to maintain the reference to assembly, so a lot of tooling support there. Now, let's see of what is the new stuff that we have in 12.7. So now OpenEdge supports alternatively the .NET runtime. So that means as a developer and somebody who maintains an application at runtime, we need to decide whether in that ABL session, we want to have the .NET framework up to version 4.8, or whether we want to have the .NET Core framework, .NET 6.0, whatever you call it. That support is there in all the runtimes, and all the Windows runtimes that support GUI for .NET right now. So that is the 32 and the 64-bit GUI client, the web client, the character client, and PassOE. Since we're talking about 12.7, there's no classic app server on this list anymore. So by default, the .NET Framework 4.8 is used, but you can use the -CLR net core startup parameter to use .NET 6.0 instead. So let's document it in the what's new documentation as expected. And the difference or the specific for using .NET Core in the ABL are documented as part of the GUI for .NET documentation as well. what are the prerequisites? We need to install the .NET Runtime or the SDK ourselves, unlike the .NET Framework, which is included on any modern version of Windows. So you cannot get a Windows 10 or Windows 11 PC without a 4.7 or 4.8 version of the .NET Framework. And through the Windows updates, you would, as of today, always be having the 4.8 framework. The .NET 6.0, .NET Core frameworks, they are considered to be less independent from the operating system, not such an integral part of the OS. You can download the installer from there, or you can use the command line installer winget, which is a package manager for Windows applications, much like NuGet for .NET developers. Their startup parameters, the same startup parameters that could have been used for the .NET Framework in the past. The new one is the first one, CLR Net Core, to use the .NET Core framework, preload CLR to load the framework runtime, not just when it's needed, but when the application starts. And there's the -assemblies parameter that points to a folder that contains the assemblies XML file for deciding which assemblies we need at runtime. Assemblies is a different thing. First, .NET Framework assemblies cannot be used in .NET Core. That are different binaries. It's different compiler, different runtime. So before .NET Core, we knew there were the classic Windows DLLs, then there was the .NET assemblies, and now we need to distinguish the .NET assemblies between either .NET Framework or .NET Core or .NET 6.0 assemblies. .NET Framework assemblies could be installed in a specific Windows folder. It's in the C Windows folder, called Global Assembly Cache, for sharing assemblies between different applications. That is no longer possible in .NET Core. .NET Core expects that every application brings the assemblies that it needs by itself. And there's some other specific differences about how you manage them. By default, if you do not do, relatively complicated things and load assemblies yourself, you need to have them all in a single folder. In the 4.8 framework, Microsoft allowed us to have them in a structure with multiple subfolders, but that's no longer possible in that way. Like Microsoft .NET applications and ABL applications that uses .NET components, typically the source code is compatible, but not the R code. So when you have an application that should be migrated from .NET Framework to .NET Core, you definitely will need to recompile the application. In that, at least, in some rare cases, you might have to change the source code. The reason for that is that the R code includes references to the .NET assemblies that are used. And since the .NET assemblies are not shareable, they typically have different names, different version numbers. You need to recompile. You see that if you look at an R code in a editor that can show binary files, like here, that near the end of the R code, you see the references to the .NET assemblies that are used by that R code. And yeah, this, for instance, the .NET Core library that is referenced there in the highlighted text, and in the .NET Framework, that assembly is just not accessible. A little bit the disappointing thing, well, it could be disappointing. When I started using GUI for .NET in the early pre-beta versions of 10.2a, I basically had the same status. I was also no visual designer and had to hand code all my code. But as of today, for .NET Core in the Progress Developer Studio, the .NET Visual Designer does not support being used in the .NET Core runtime, but I'll show soon that that's not such a bad limitation. There's no code completion as well. The class browser is not there. The assemblies XML maintenance in Developer Studio doesn't work with .NET Framework, with .NET Core assemblies. There's another tool that works with that. Riverside, they promised me that in a couple of weeks they will have .NET Core support in the VS Code language server, so for writing code that could be an alternative for now. However, the API difference between .NET Framework 4.8 and .NET 6.0 are not that significant. So in most cases, you will be able to write your code with .NET Framework and execute it with .NET Core. And then you get some of the tooling support that otherwise we'd be missing. So when you start loading the Visual Designer in the .NET Core, you get this ugly runtime error. And it just basically means that, well, the .NET Visual Designer of the Progress Developer Studio cannot be loaded in the .NET Core environment. So, but the solution to that is, well, we can use the GUI for .NET Visual Designer with the .NET framework. The code that we generate there, the Visual Designer is nothing else than a code generator, is compatible to the .NET Core framework. So if I go into my Developer Studio, I do have one project here that is configured to use the .NET Core runtime. So we see the -CLR.NET Core startup parameter here. And I have another project that doesn't do that. And there in a test folder, I do have some simple .NET forms. Where's it? Simple form or the simple infragistics form. That has an empty infragistics grid, and I could add other infragistics controls here. So that's using now the .NET Framework 4.8. If I add the Ultra Toolbars Manager there and create just a basic empty ribbon and save that. And I take the source code and the resource file that might contain relevant information as well. And I copy that file into the project that's configured to use the .NET Core framework. And when I recompile that folder, that one, that didn't. So now I got the error message that I've showed you earlier, because it's trying to open the Visual Designer by default. But the actual problem is I'm not referencing all the classes yet. The ribbon is not yet part of my assemblies here, but let's do the same with this simple form. If I open the source code of that one, that has been designed in the Visual Designer, and I run that from here, then I'm seeing on which screen is that hiding now? You can see the icon there, but I don't see the screen. There it is. So I see the form is running here. It's running in .NET Core. There are two ways I can tell that. One is on this button, I'm showing the .NET Framework version or the .NET Runtime version 6.0.20. And the other is the standard icon for .NET Forms. You see that on the slides. The standard icon for .NET Forms has changed. So this colored icon here is the .NET 4.8 framework. I can run the same screen there, and the just black one is .NET Core. So this copying of forms over, it works. It may not be the most productive for now, but typically during development of applications, you could be using the .NET framework, and then when you deploy that, you could be using .NET Core. So it's not something that I would be changing multiple times a day during development. It's more like development.NET framework runtime could be .NET Core. we would deal with this in a slightly different way. In our developer framework, we have implemented our own visual designer. It's also using the .NET Visual Studio Designer components at runtime in an OpenEdge GUI client. We use the same design. We use that designer to update UI designs in a repository database, and then we can use this designer, this GUI designer, also to design web applications through a repository database. So that's how it could look like for designing a form. We also get the snap lines and see the controls there, store that to a database. And here we also can distinguish between tooling and runtime. So the first phase that we're currently working on is making sure that our framework runtime works fully using .NET Core. And we leave the visual designer, our own visual designer, in the .NET framework. And at runtime, we use .NET Core. And then in a later phase, we still believe that we're starting with this later this year, we'll be porting our visual designer to use the new visual designer of the .NET Core framework. The new visual designer isn't that much different. It's just the way it started is different. And Microsoft says because of new settings that you can do, you'll have better what you see is what you get. OpenEdge Ultra Controls, Progress has decided not to continue shipping them. So if you are using the Ultra controls in the .NET framework and you want to go to .NET Core, you have to obtain a license of the Infragistics.NET controls from Infragistics directly. You would then install them through NuGet. One thing that you will realize is that the naming pattern for the assemblies is different. So currently in the .NET framework, Infragistics assemblies have 2 times the version in the fully name. One is as part of the file name, and then there's the version information. This part of the version in the file name, Infragistics has dropped that in the .NET Core versions, which makes updating versions a little bit easier. When we look at the suite of .NET components that we've been using over the year, then majority are the OpenEdge Ultra controls, but we also use some of the red controls. Both all the controls that are using there are partly we've verified that already, partly we've just read the documentation because that's still an ongoing process, but we see there's nothing missing there. We're using ProPass in our tooling a lot. It's a tool that allows us to read ABL source code. And the way that we've been using that in the past has been through a .NET package that wraps a Java virtual machine into .NET. That project has been dormant for the last 5, 6, 7 years. But last year, this project revitalized, and there is now .NET Core variant that we're testing now, and it looks that we can use that to port ProPass to .NET Core as well. Ceph is the Google browser as a .NET component. That's available as a .NET Core component with some Microsoft assemblies that we use for desktop integration, etc. Those are, of course, all available as .NET Core variants. There's one control that we're using now, tooling. It's like an ERD designer for business entities. We do have the source code of that tool, and we're planning to port it to .NET Core ourselves. So from looking at this, it means there's some work. There's a lot of testing needed. With ProPass, we need to do some R&D to port that to .NET Core. With Crane.it, we have to do some R&D to build our own version of for .NET Core for that. We haven't seen any real blockers yet, but it is some work that we have to do. And that brings us to the question, why would we want to do that, or why are we doing that? Well, with .NET Core, we're just having the latest version of .NET, whether you call it .NET Framework, .NET Core, or .NET 6, whatever. Microsoft has said the .NET Framework 4.8 will not get any significant new features. So for future-proofing our application development, for as long as we stay on the Windows desktop, we need to be ready for .NET Core. I don't see there's any other option. We cannot sit there and say, no, we stay in the .NET framework for as long as it's possible. More and more libraries that provide integration or APIs or whatever will increasingly be available just for .NET Core and no longer for the legacy .NET framework. I'll show you later some benchmarks that I did. .NET Core seems to be faster also in the OpenEdge environment. I haven't really done UI benchmarks because UI benchmarks are really hard, and we don't have a huge UI application ported over yet. But the benchmarks that I've did are already pretty promising. Well, and I think if you look at the Progress Ideas section on Progress Communities, you see that sometime earlier this year, the idea for .NET Core support on Linux has been switched from under investigation to in progress. So it seems that Progress is working on supporting .NET Core in the AVM also on Windows. And everybody who wants to hear more about that should probably be talking to Progress Product Management or look at recordings of the roadmap sessions that have been there earlier this year. So let's look at some samples how we can use .NET Core or .NET. So this sample here doesn't require .NET Core. Let's do some simple trigonometry. Every now and then, able applications need trigonometry for calculating of distances, for calculating of how much you can put in boxes or whatever. And the ABL is pretty limited with the mathematical functions beyond addition, subtraction, multiplication, and division. So let's look at code that can calculate the distance between the Progress HQ in Burlington and our main office in Cologne. On a perfect sphere, we would be assuming, we're assuming the world is a perfect sphere and not slightly oval. So there are various functions for that. One is the Haber sine formula, and that requires us to use sinus, cosinus, tangents, square root functions, etc. We need pi as a constant. Well, a pi as a constant is something we could solve by typing it with, I don't know, 16 digits into a preprocessor variable, whatever. But any version of .NET has that. And the code that we have here is actually line by line translated from a JavaScript sample found on Stack Overflow. So I have to confess that I've been doing copy paste from Stack Overflow here. And I know that Peter will be using this for the next 10 years against me. In the only changes I had to make to these functions is, well, the function declaration requires a return type, mass as a .NET library or a .NET class that provides these functions in the JavaScript sense. There was a period, not a colon here. We have the period at the end, not a semicolon, etc. But that's basically all the changes that I had to do to this code. Then I can run this, and it returns a result which looks pretty trustful to me. 5,750 kilometers seems to be the distance from here to the Burlington office. I'm not going to walk it because there's too much water in between, but yeah. So, and there are much more use cases like that you can just easily use from the .NET framework. And we don't, with the .NET framework, we don't have to do ugly DLL external function declarations or whatever. We just embed the assembly into the configuration, and then we can use the classes just like you find lots of samples for. We can also use that to consume different APIs. Microsoft more and more provides asynchronous APIs. And if you read a lot about what makes .NET Core faster or .NET Core applications faster than .NET Framework applications, this tendency to do more things asynchronously seems to be part of that. In the past, many Progress developers have probably been using the Microsoft.NET Web Client class to do similar things than what you can do with the Progress HTTP client that's built in. if you now look at the documentation of the web client class, you will find out that it's obsolete. It should no longer be used. It should be replaced by the HTTP client class of the .NET framework. So if you look at that, on the right-hand side, we see all the methods there. They all have the naming suffix async. So all the methods that this new .NET HTTP client class provides are asynchronously. So we need a way to deal with them. In the .NET world, in C#, we would be seeing code like this, and we would be finding at two places there in the source code the await keyword. And await is a little bit like a wait for. It's doing something and it waits for its completion. So the first thing it does the asynchronous request to this website, waits until it gets a response, and then the second line string response body equals await response.content.read as string async is reading all the data that's coming from the web client web request response and appending it to a string. And depending on the size, that could take some time. And because it's asynchronously, the runtime is not blocked. The runtime could be other things in the meantime. So the await operator is in the end just syntactical sugar. So it's something that is used by the compiler, and then the compiler understands, okay, when that's used, then I need to translate it into additional code. So await itself is not really a runtime feature. The concept for supporting asynchronous operations there is very similar to promises used in most JavaScript frameworks. But in the ABL, we do not have the await operator or such a keyword whatsoever. What the await actually does, it provides some functionality around the fact that these asynchronous methods follow a certain pattern, so a coding convention, and they return a task instance. It's an object that represents the asynchronous operation. And in the ABL, we can handle the asynchronous operations without the await keyword by interacting with these task instances. So I do have an example here for working with the HTTP client, a couple of usings, a couple of variable definitions, one for the HTTP client, then one for the get task of the web client. Then I define a file stream so that I'm downloading a file and writing it to a file, and that's done asynchronously too, using a copy to tasks or using a task instance. And there's a cancellation token. That's something I'll explain in a second. So, and then the code to initiate the request. So this is here downloading from a test website a 100 megabytes file, which takes a couple of seconds depending on your network bandwidth. So I create the instance of the HTTP client, and then I invoke the getStream async. And this object, the getStream task, is not directly providing the response of the request. It is representing the asynchronous operation that's being happening. And then I create a stream to write the file to. And then the copy to method is also asynchronous. There we see that the copy to method is executed on the result of the get stream method. So there's one stream that provides me the data of the web response, web request response, and then I use the copy to method of that stream to write it to another stream. To both asynchronous operations, I'm providing a token reference of this cancel token. The cancel token is a pretty simple concept. It's an object that I keep a reference on, and I could use this object to call the cancel method. And the asynchronous methods on their own control could be checking whether I have canceled or not, and based on that decide to cancel. So it's not really a hard cancel. It's more like I signal that I want to cancel. So then I have a loop while the copy task is not yet completed. I could write a message to the log file that I got a chunk. So that's on the UI that would be used to show some animation. then I wait for a tenth of a second, and the commented out code there would be my ability to cancel that. So here, the asynchronous nature, it does not only potentially make it faster, but it also gives me the control to cancel that operation on whatever condition, either time or the size or whatever makes sense for that API. One thing which is very important at the end, we need to close the stream, so the dispose in line 64 there should not be forgotten. So let's look a little bit about some benchmarking. There, if you read about it, performance improvements in the .NET Core world all over the place. Some are pretty generic with huge impact, and some are very specific. There are blog articles by Microsoft. Microsoft writes a lot about what they do in the development of the framework. And one example is here parsing a GUID. The .NET framework and .NET Core have a specific data type for GUIDs, and that's used all over the place. And when GUIDs are being received in web service responses, we get them as text data, but internally they're binary data. So this operation of transforming a text GUID into a binary GUID and vice versa is something that happens quite often in the .NET framework. And so what they state in this blog article here is that there have been improvements all over the place in various versions. But one, especially in the last version, is they came to the conclusion that dealing with culture info, current culture, which has to do with code page conversion and conversion of delimiters in decimal numbers, etc., is not needed for GUIDs. So they've just realized that the requirements don't need this, and taking that out was quite significant differences. So in the .NET Framework 4.8, which we're using by default in OpenEdge, it takes 251 nanoseconds to pass a string GUID into a binary GUID. In .NET 6.0, it's only a seventh of the time, 33 nanoseconds. So that's quite a lot. So let's see if we can see that in the ABL. We can certainly not see that if I'm doing that only once, but if I do that 500,000 times, then we can see a significant difference. So that's a program that I'm running. And the way I'm running this is I'm using a command line. Make it a little bit bigger. So that's my Pro N 412.7. And I have a program GUID.p. That's the program that I have on the screen. The first thing I do is I delete the R code, because the R code ties the program to either .NET Core or .NET Framework, but I want to test both. So now I'm going to run provin -batch -p GUID.p. I'm going to first do it with the classic .NET Framework. And now I've made a mistake. I should not be doing this provin. I should be making it with a character client, because otherwise the batch session will complain that it doesn't have any output. So let's do that with the character client. And it takes 8.6 seconds. So it seems to be slower than when I did it earlier today. That's probably because of the webinar that I'm streaming. So now let's do the same with the .NET Core CLR. And it finishes in 6.7 seconds. So the difference is more significant than what I had earlier. So what I had earlier, I had 5 versus 6 seconds, but still, that's 20%. So we're not seeing the 7 times faster, but that I didn't expect, because I'm doing that in ABL loop, so the looping has some overhead. And I know that for the bridge, well, I'm passing 500,000 times a character value to a .NET method. The invocation of .NET methods under the covers is always dynamic invocation. So there's a lot of overhead on the bridge, but still .NET 6 sticks to the promise of being faster. So Second example, oh no, let's first do the math. So in the timings done in the Microsoft block, which was on a different machine than mine. So there might be your mileage may vary aspect. But the difference between .NET 6 and .NET 4.8 on a single call was 220 nanoseconds. I'm doing that 500,000 times. That accumulates to 0.1 of a second. So the additional 0.8 seconds are gained somewhere else. So I guess that's just either Progress has found some screws to turn on the bridge themselves, or just the part of the .NET core that the bridge uses, which has gotten faster. Whatever it is, probably a combination of all that leads to the fact that this program is significantly faster. And you may see, oh, who does this 500,000 times? But when we see this constantly about over dealing with data, if you look at what happens when you have a .NET grid with lots of cells and lots of rows, all these operations that convert ABL data into .NET data and access properties and assign it here and there, this is quickly happening many, many thousand times for just starting a screen. So I'm expecting that these performance improvements will substantiate when we're starting to measure performance of GUI for .NET applications. So for the function that calculates distance on a sphere between 2 points, I see also significant performance improvements. I'm doing that 10,000 times. Well, why do I do it less? Well, what happens in these functions is more than just doing a GUID. I call various of the trigonometrical functions. I access P multiple times as a constant, etc. And what I see here is when I do that 10,000 times, it's a difference between 2.4 seconds to 1.9. So that's still a 20%, or that is a 20% improvement. And again, if that was Microsoft or Progress or both, congratulations for that. I think that's a very significant performance improve. Maybe would have been hoping for 2 times as fast, but well, let's be realistic. 20% is significant. Good. With that, I'm coming to my end here. I'm gonna ask for questions, and while you might be thinking about questions, I'm gonna introduce our next webinar in 3 weeks from now, 2 weeks from now. Docker Live Coding, our DevOps architect, Daniel van Dorm, will be using that hour to start with nothing. And at the end of the hour, he'll be having a PaaS running a Docker container, serving a simple web service. You'll find that on our events page. Over the last couple of months, we've been doing this as a series of webinars with roughly 1 a month. Most of those webinars have been recorded. Today's webinar will be, well, it's recorded and will be put on the website probably tomorrow on Monday. So that's something for you to enjoy. And later this year in November, the PAC Challenge is coming back to America. So in November 13th to 15th, PAC Challenge will be taking place in Burlington, Massachusetts, just around the corner of the Progress office. OpenEdge focused, purely technical content with over 50 breakout sessions. You can check the website. I don't know if it's already possible to register as a delegate, but that will probably be open in a couple of days if it's not yet already. The program is being organized, and first part of the program should be on the website in the next couple of weeks. Lots of parts of the program will be the same as the European PAC Challenge. So if you look at pacchallenge.eu, you could probably get an idea of what kind of contents you can be expecting at that conference. So and with that, I'm going to hand it to questions. Okay, so I think there are no questions. Then, well, thank you for your time. Hope you found that webinar useful. If you want to reach out to us later, just drop us an email. And besides that, I hope to see you at a conference either on this side of the pond or your side of the pond later this year.